Let's have another question. That is, a question is of the form, if x square plus y square is equal to 25xy, then you have to prove that 2 log x plus y is equals to 3 log 3 plus log x plus log y. That is the question. We have to prove it. Okay, here is the question. You have to think about it. To proving this using this condition, x square plus y square equals to 25xy. Using this condition, you have to prove this equation. How to prove it? Is there any x square plus y square in this question? X square plus y square? No, it is not given. But it is given x plus y. Can we apply here? It is not x plus y, no. It is x square plus y square. We need x square plus y square. So in these kind of questions, what you have to do, in x square plus y square comes in which identity? We have one identity that, okay, we know that x plus y whole square. Okay, this identity you have to use it. That is the main step. X plus y whole square is equals to x square plus y square plus 2xy. This identity you have to use. In that we can apply this also, and we will get this answer also. So this is the main step. Okay, in the question it is not given that you have to use this identity. Okay, but you have to use your techniques to prove this. So our technique is using this identity x plus y whole square. This here, what is given? X square plus y square is given as 25xy. So here x square plus y square, here I can write as, in place of this I can write as 25xy plus 2xy. So that is the next step. Okay, first using this identity. Now x plus y whole square equal to this. Now this is x y xy. These two are the like terms. Okay, we can add the like terms. So 25 plus 2 is 27xy. This identity we are going to use. We have added these two terms because they are the like terms. So 25 plus 2 is 27xy. Now we got here. Now after getting this, we are not getting this answer, no? The answer is in the form of log. So what we have to do? We have to apply log on both the sides. Apply log on both sides. Why we have to apply? Because what the answer we have to get, that answer it is coming in the form of log. That's why we have to apply log on both the sides. So log x plus y whole square equals to log 27xy. Okay, we have applied log on both sides. So what is the first step here? First we have used the identity x plus y whole square equals to x square plus y square plus 2xy. Then after that it is given here x square plus y square is 25xy. So in place of x square plus y square we have put that 25 into xy. Now these are the like terms, 25 plus 2 27xy. But here also we are not getting the answer. So what is the next thing? Because the answer we have to prove, it is coming in the form of log. So we have to apply log on both the sides. But here we got the answer. We get this thing, but is it the answer? No. Again we have to simplify this to get this answer. Let us simplify. Log x plus y whole square is equal to log 27xy. This we are supposed to simplify. How to simplify this? Using the properties. What are the properties? Here we can use the property that is in the form of this log x to the power n is equal to n log x. This is the first property we are going to apply here. So these two we can shift here. 2 log x plus y. Okay, we got this 2 log into x plus y. Now what about this? Log 27 into x into y. As I told you, log a, b, c we can also write as, this is another property, log a plus log b plus log c. So this is the another property we have to apply here. So log 27 plus log x plus log y. So here come it, 2 log x plus y. We got the left hand side term 2 log x plus y, but here we are getting log 27. We got log x and log y also we got. What about this 27? We have to factorize to get this 3 log 3 form. 27 we can also write as 3 3 is a 9 and 9 3 is a 27. We can write as 3 to the power 3. Is it correct? 27 is 3 3 is a 9, 9 3 is a 27. That means 3 comes 3 times. That we can also write it as 3 to the power 3 in the exponential form. So here 2 log x plus y is equal to log 3 to the power 3 plus log x plus log y. So 3 we can write here 3 log 3 plus log x plus log y. So do we got this? 2 log x plus y equals to 3 log 3 plus log x plus log y. Hence proved. Okay, we got this answer. Now we have another problem, that is if log x plus y divided by 3 equals to half into log x plus log y, then find the value of x by y plus y by x. This is the problem, how we have to prove it. Okay, if log x plus y divided by 3 equals to half into log x plus log y. This condition is given, that means this is equal to this. Then you have to find the value of, then find the value of, okay, you have to find the value of x by y plus y by x. You have to find the value of x by y plus y by x if it is given. If log x plus y divided by 3 equals to half log x plus log y. If it is given, using this you have to find this value. Find the value of this question, x by y plus y by x. How to do this? To do this, what we have to do? In the previous question we have used the identity, that is x plus y whole square equal to x square plus y square plus 2xy. But here, are we going to use the same thing? Let us see. No, I think we are not supposed to use any identity over here. But here we are not using this. First, what we are doing, we are just to this we have to solve it and bring it in the form of log x. This is log 1 log here. It is in there are 2 terms here. This you have to, okay, you have to solve and get in the form of log n form. So how to do this? Log x plus y whole divided by 3. Here same thing we are using, is equal to, here it is log x plus log y. If plus is there, what we have to do? Log x into y. Okay, first I will write this, log x plus log y. This we can write as log x plus y, we can write as log x into y. Is it right? Log x plus log y, this we can also write as log x into y, right? Now what about this? Now x into y is the thing. Now this 1 by 2 can be write over here, log xy whole to the power 1 by 2. Can we write like this? Because we have a property now, that is n log x, we can write as log x to the power n. Can we write like this? Yes. So n we can write here in the exponent form. So log xy is one term now here. So x into y whole power 1 by 2. 1 by 2 is nothing but log root xy. Is it root? Yes. So now this is the left thing, same thing should be there. Then we have log x plus y whole divided by 3 equals to what the thing we are getting? Log root x. Now see here, in the left hand side we are getting log this term equals to, in the right hand side, actually this question was there, but after solving this we got log square root xy. Here is log this equals to log this, that means here both these are equal to log, that means these terms are equal. Okay, that means these and these are equal. X plus y divided by 3 is equal to root x. Okay, here we can't take the common thing, log this equals to, we can't take this, na? Here two terms are there, so we can't take this term common. So after solving this we got log x plus y divided by 3 equals to log root x, that means this and this are equal, we can take it as equal here. This is the main step over here. Okay, after using this we will solve and get the value of x by y plus y by x. This step you have to remember. Now what we can do here, are we getting this form? No. So what we have to do, root xy is there, root xy is not there. So what we can do over here, we will apply square on both sides, squaring on both the sides. Why we have to apply square? Because root xy is there, we don't want any root value here. So we are applying square on both the sides. X plus y divided by 3 equal to root xy. What we are doing, we are applying square on both the sides. Okay, we have applied square on both the sides here. So here square and root get cancelled, because this is a whole square root, na? Whole square root xy. That means as we have applied square, this square and the root get cancelled. Now what we have to do here, this is in the form of x plus y whole square. Okay, x plus y whole square divided by 3 square, that is equal to, here we are getting xy. This square is applied over both the numerator and denominator. So square is, we have to apply for this numerator as well as in the denominator, 3 square. This what we have to do, we are using the identity here because it comes in this form only. What is the identity? X square plus y square plus 2xy is equal to xy. Now here what is 3 square? 3 square is 3 3s are 9. 9 we can shift here. Can we shift 9 here? Yes, because numerator, this is the denominator. If you want to shift there in the right side, it will goes into the division in the multiplication form. Now after that, 2xy, 9xy, they are the like terms. So next step is x square plus y square equal to 9xy. 2xy, if we shift there, this plus 2xy will become minus 2xy if we shift to the other side. Now these are the like terms. Like terms we can add and subtract. So 9 minus 2, 9 minus 2 how much? 7xy. X square plus y square is equal to 7xy. See, still here we are not getting this. So what we have to do? We are not getting this form, na? X by y plus y by x. We want this form. So what we have to do? This x into y, we will shift this side. That is x square plus y square is equal to 7. We will keep 7 as it is over here. This x and y. Okay, it is in multiplication form, na? If you want to shift to the other side, it will come in the denominator. To the other side, it will goes into the denominator xy. Now, these other two terms, we can separate this denominator to both the terms. Separately, we will write x square by xy plus y square by xy is equal to 7. X square and x get cancelled, y square and y get cancelled. Here x square means there are 2x, x into x. So 1x from here, 1x from here we have cancelled. So what is left here? 1x. And x is cancelled here. So left one is y. Plus y square and y. 1y and 1y get cancelled. From y square only 1y is left. So y by x is equal to 7. So look here, that is the answer. X by y plus y by x is equal to 7. So 7 is the answer of this. Okay. Now let's have a question, that is, if 2 to the power x plus 1 equals to 3 to the power 1 minus x, then find the value of x. the question is given in the exponential form. Using that we have to find the value of x. If 2 to the power x plus 1 equal to 3 to the power 1 minus x, it is in which form? Exponential form, na? Then you have to find the value of x. Then find the value of x. Can we find the value of x? Because x is given in the exponent form, in the power form, and it is given. How to find it? Is it easy to find? If the question, if this is an equation, na? If in the equation, if the base is x form, it is easy to find. But if the value of x is coming in the form of power, it is given. I mean, it is given in the exponent form. How to find the value of x? So in this kind of problems, what we have to do, what we will do, we will apply log on both the sides, right? Why we are using logarithms? Logarithms we are using to find the value of exponent only, no? That's why here we have to find the value of exponent only. We have to find the value of x, that x is in the exponent form in the given question. So because of that, we are applying log on both the sides. Let us start the answer. Apply log on both the sides. That means log 2 to the power x plus 1 is equal to log 3 to the power 1 minus x, right? Now after this, what will be the next step? Using the properties. What are the properties? Here that property we will apply. Log x to the power n is n log x. This property we will apply here. So this complete x plus 1 we have to shift, okay? X plus 1 we will shift here. X plus 1 into log 2. You have to put bracket also. Equals to this here also. 1 minus x we will shift here. 1 minus x into, we are not just substituting here because we have the property. Using the property only we are shifting this exponent, and we can shift here, na? Both are equal. That's why 1 minus x we are shifting here. So 1 minus x into log 3. Now after this, what we can do? We will open the bracket. That means log 2 you have to multiply to both x and 1. X into log 2. Okay, x into log 2 plus 1 into log 2 is log 2. That is equal to 1 into log 3 is log 3 minus x into log 3 is x log 3. This is the equation we got. But then also we are not getting the value of x. To get the value of x, what we are doing? What are the x terms? We have 2 terms here and 2 terms here. So where is x? X is here in the first term. Here we don't have x. Here also we don't have x. Here we have x. So these x terms we are writing to the left hand side. X log 2 is already here. So put x log 2 here. This minus x log 3 we are taking and we are shifting to the left side. So minus becomes plus. Plus x log 3 is equals to this log 3 as it is. Since x is not in this term log 2 we are shifting to the right side. So plus log 2 becomes minus log 2. Now after that, what we have? Here we can take x common now. We can take x common. X log 2. See here, we are taking x common. So x, make the bracket, log 2 plus log 3 is equal to log 3 minus log 2. Up to here we got, but actually we have to find the value of x. Then what is the next step? Now see, we have this step, x into log 2 plus log 3 equal to log 3 minus log 2. So what we will do? We will keep x as it is over here. This is complete x into log 2 plus log 3. So these we have to shift to the right side. How to shift? It is in multiplication form now. X into log, this is one term complete, x into this. So we are shifting this log 2 plus log 3 to the right side, and so it will go into the division form. Okay, so this is the thing, 3 into log 2 plus log 3 equal to 3 log 3 minus log 2. But what we have to get the value of x now? This is the continuation of the answer. So what we are doing, this is x into log 2 plus log 3. This is in multiplication form. We have to find the value of x only. So we are keeping x only as it is here. Only x is equal to this log 2 plus log 3. Complete this thing, we are shifting to the right side. So it is in multiplication form. If you shift to the right side, it will goes in the division form. Log 3 minus log 2 divided by log 2 plus log 3. Okay, this complete terms, this complete thing, log 2 plus log 3, it will goes in the division form. Now log 3 minus 2 means log 3 by 2, right? Log 2 plus 3 plus log 2 plus log 3 means log 2 into 3. That is log 3 by 2 divided by log 2 3 is a 6. So this is the answer of x. This is the value of x, log 3 by 2 divided by log 6. This is the answer. This is the value of x. Now we have another problem, that is if 2.3 whole to the power x equals to 0.23 whole to the power y equal to 1000, then find the value of 1 by x minus 1 by y. The question is, if 2.3 whole to the power x is equals to 0.23 whole to the power y equal to 1000. All these three are equal. Then you have to find the value of, find the value of 1 by x minus 1 by y. 1 by x minus 1 by y. This is the question. Okay. With the help of this, how to find the value of 1 by x minus 1 by y. So what we can do here, since all these three are equal now, what we will do, first step, we will take this and this equal. That is 2.3 whole to the power x is equal to 1000. 1000 we can write as 10 to the power 3. Can we write 1000 means 10 into 10 into 10? That means we can also write as 10 to the power 3. Right? 1000 is 10 into 10 into 10. That we can also write as 10 to the power 3 in the exponential form. Now the next step here is, this x we have to shift that side. Okay, that means how we can remove this x? If we divide both the sides by x, 3 by x, both the powers, exponents we are dividing by x. So these x and these x get cancelled. We are getting 3 by x as a exponent of 10. 2.3 we are getting 10 to the power 3 by x. Okay, this is 2.3. Next, now 0.23 whole to the power y is equal to 10 to the power 3. What about that? Next to 0.323 whole to the power y is equal to again 10 to the power 3. This you have to remember, this that we are going to use in here. First 2.3 whole to the power x is 10 cube. This exponent we have shifted to the other side, so it will goes in the denominator of the exponent only. So here 2.3 equals to 10 to the power 3 by x. Next we are equating these two. So 0.23 whole to the power y. So this is nothing but we are getting 0.23 whole to the power 10 power 3 by y. Same thing like this. This is 2.3 and this is 0.23. So 0.23, this y we are shifting here. So it comes like this, 10 to the power 3 by y. Now this is the decimal form. Now here we have this value 2.3. So what we are doing, this 0.23 we are writing as 2.3. 2.3 divided by 10. Can we write like this? This and this are equal only. Okay. 0.23. Why? Because we have 2.3 value. That's why we are writing in the form of 2.3. What we are doing, we are shifting this point over here. So point comes here 2.3. If we are shifting point means we have to add 1 0, because point we are shifting 1 digit to the right side. We are shifting the point from here to here. That means 1 digit difference. 1 digit difference means 1 0 you have to add in the denominator. 1 is always present, that 1 0 you have to add. 10 is equals to 10 to the power 3 by y. Now this 2.3 we will write as, in the place of 2.3 we will write 10 to the power 3 by x. 10 to the power 3 by x by 10 is equal to 10 to the power 3 by y. Okay. In the place of 2.3, 10 to the power 3 by x we are writing. So 2.3 is no more left there. 10, 10, 10. Everywhere we are getting 10. So what we can do? What is the power of this 10? Power 1. So 10 to the power 3 by x. Bases are same. Now we have an identity. A power m by a power n. This we can write as a power m minus n. Similarly, 10 power 3 by x. This n becomes minus n. So here what is the exponent of 10? 1. So we are writing minus 1 as an exponent. This we are substituting in this form. That is equal to 10 to the power 3 by y. Now look here, left hand side and right hand side, in both these places bases are same. Here also base is 10, here also base is 10. Now bases are same means powers are equal here. So we are equating the powers. Hence bases are same here. So 3 by x minus 1 is equal to 3 by y. Right. Bases are same, exponents are powers are equal. That means we are equating the powers. Why we are equating the powers? To get this value 1 by x minus 1 by y. To get this value we have to, we are not supposed to use this basis. So but just we are using the exponents, equating the exponents. If we equate the exponents we will get this value. That is the step you have to remember. Now 3 by x, 3 by y if we shift here, minus 3 by y equal to minus 1 becomes plus 1. Now here 3 is common now. We can take 3 common. 1 by x minus 1 by y equal to 1. Then 1 by x minus 1 by y is equal to, these 3 we have to shift. Where it will go? It will go in the denominator. So 1 by x minus 1 by y is equals to 1 by 3. So the value of 1 by x minus 1 by y is nothing but 1 by 3 using these steps. You have to remember all these steps. Okay, so that is the answer. Hope you have understood the previous question. Hope you have understood the previous question. Similar kind of questions are there in your textbook and like examples, and you can also create your own questions, okay, to practice these kind of problems. Now we have the last question. That means okay, that is there are two questions. That is how to prove that log 2 is irrational or rational. You have to justify your answer. And next is log 100 rational or irrational. You have to justify your answer. The question is first one, log 2 is rational or irrational? Rational or irrational? You have to justify your answer. And another one, okay, log 2 is rational or irrational. You have to justify your answer. And next one is log 100. Log 100 rational or irrational? That also you have to justify. Okay, first one, how to justify? What is log 2? Log 2 is having some value. It can be rational or irrational. Okay, what is the base here? Log 2 base. I told you now, if base is not given, you have to take it as 10. Log 10 base 2. Let us write. Let log 2 base 10 is equal to x. let us take it as x. Okay, this is the logarithm form now. Logarithm form, that is log n base a is equal to x. This logarithm form let us convert in the exponential form. A power x is equal to n. Let us see what we can get. Log 2 base 10 is equal to x. Let us convert. A is nothing but 10 to the power x you have to find, n is 2. So, can you tell me what will be the value of x, so that you will get the value as 2, 10 to the power what value of x, so that we will get answer 2. Log 2 base 10 is equal to x. We are equating this. We have to convert in the exponential form to check whether it is rational or irrational. Log n base a is equal to x. Logarithm form you have to convert in exponential form. This is the general form I am writing here. General form. Log n base a is equal to x. That means a to the power x is equal to n. Okay, I told you na, exponent is the answer of logarithm. So, log 2 base 10 is equal to x, that you convert in the exponential form. A is 10, exponent answer is x, and answer is 2. Can you tell me for what value of x you will get the answer 2? If we take 10 to the power 1, what is 10 to the power 1? 10. What is 10 square? 10 10 is 100. See, after taking 1 and 2, we are not getting the answer 2. We have to put the value of x as 1, 2, some natural number. After putting some natural or else we can say rational, some irrational number, after putting some irrational number, we are not getting the value of 2. That means there is no value of x, so that 10 to the power x will get the answer 2. So, in this case we can say that log 2 is a irrational number. If we get 1 or if we get 2, suppose if we get 10 to the power 1 10, answer is not 10, no, answer is 2. If I take 10 square 100, is it 100? There is lots of difference between 2 and 100. So, that is why we can say there is no value of x, so that the 10 to the power x gives you 2 value. So, we can say that it is a irrational number. Log 2 is a irrational number. Okay, but we can say that, but here 2 can't be written as, okay, 2 can't be written as 10 power x for any value of x. This 2 can't be written in the form of 10 power x. So, we can say that log 2 is nothing but it is an irrational number. Therefore, log 2 is irrational. So, this is the first one. First one is log 2 is a irrational, and we have justified here. Now, let us do the next one, log 100. Okay, let us do another one, log 100. Log 100. Let log 100 equal to x. Base is not given, we can take it as 10. Log 10. 100 can we write as 10 square? 100 is nothing but 10 into 10. Huh? 10 10 is 100. This we can write as 10 square. So, 100 we can write as 10 square equal to x. Now, we will use the property 2, we will shift here. 2 log 10 base 10 is equal to x. Now, what is 2 log 10? This is 10 and this is 10. We have a property log a and this a. If both are same means we will get one answer. Using this property, we can say that 2 into 1. This is nothing but 1 equal to x. That means 2 ones are 2. That means x is equal to 2. Here we are getting the value of x 2. That means log 100. The value of x is 2 means it is nothing but 100. No? We have used that log 100 is equal to x. That means log 100 is nothing but 2. We got the value of log 100 as 2. 2 is a rational number. So, log 100 is a rational number. Therefore, we can say that log 100 is rational. Okay. So, hope you have understood all these problems. So, this is the end of our chapter, first chapter, real numbers. But you have to practice the problems which are given in the textbook as an example, as an exercise problems, and you have to practice a lot, and you have to create questions also of this type, and you can practice. You need a practice a lot to be perfect in this chapter. Okay.